Setz dich gerade einmal hin.
Sehr gerne.
Welcome to the ZEISS Innovation Talks, where we invite experts to talk about the latest innovations in industrial quality solutions. Today, with me here is my colleague Patrick Stempfle, Head of CMM Application Development at ZEISS. Hi, Patrick.
Hi, Julia.
Welcome. Nice to have you here.
Thank you for having me.
Can you briefly introduce yourself and tell us a little bit more about your background and how long you are with ZEISS?
Yes, sure. So I'm Patrick. I'm heading the application development team within the business unit multisensoric coordinated measuring machines, which we call CMM. And we are developing application solutions with our systems for our customers.
Okay, great. Before we start, I have a little surprise. I want to give our audience the chance to get to know you a little bit better. So we play a short lightning round.
Okay.
I give you two options. You pick one, just short and spontaneous. Okay, are you ready?
Yes, I hope so.
Okay, first question.
Yeah.
Sports event or concert?
Sports event.
Tactile or optical metrology?
I would say tactile.
Okay. Party with friends or family evening?
Ideally-wise both, but I would say family.
Okay. And X-ray or industrial microscopy?
X-ray.
Great. Thank you very much, Patrick.
You're welcome.
So today's topic is flexibility and precision with CMM innovations. And in this session, we want to talk a little bit about the latest trends and the current challenges that our customers face.
Yes.
And what innovations you are delivering with your portfolio in order to cope with these challenges.
Yeah.
So let's start with this. ZEISS IQS is well known for their CMM business for several years. I think it is more than 30 years that we provide CMM solutions, right?
You're right.
So quite a long time.
Yes.
Is CMM still a state-of-the-art technology, or aren't there other technologies like X-ray, as you mentioned, or optical 3D solutions really like catching up? What do you think?
Yeah, so it's another good question, but I think you're right, In the last decades, there have new technologies risen, such as X-ray, optical 3D, and so on. But I would say there's nearly no quality assurance process which does not rely on a CMM as a reference.
And what challenges do you observe in the industry in regard to quality assurance?
Yeah, I would say there are multiple challenges at the moment because our customers change the way they work and they produce. So at the moment, I would say speed and efficiency is most important.
Everyone talks about it, right? It's all about it.
For everyone, it's, I think, priority number one.
Yeah.
But also quality assurance moves closer to production. And this is then facing to the topic of automation, footprint. Is getting more and more important, and also multisensory machines.
Footprint of the machines that they are using?
Yes, exactly,
In order to become more cost efficient, save more time.
To save time, to do more than just one measuring task on the CMM, solve ideally-wise more than one. And also the topic of cost pressure.
Yeah.
And also the demographical change, which leads to the topic of ease of use. More and more into focus.
So systems need to be simple, should be operated very easily.
Okay. Yeah, hardware and software side. Yeah,
and how do you address these challenges with your portfolio?
Yeah, good question. Yeah.
You have a broad portfolio, so.
Yes, that's true. So as you mentioned, we have a lot of answers to those challenges, always depending a little bit on the customer's individual requirements. But maybe let's start with the Spectrum, which is one of our bridge CMMs.
Okay, but Spectrum is part of our portfolio quite a long time. So what's new about it?
Yes, indeed. Yeah, it's quite a long time there, but we launched a new Spectrum last year.
Okay.
And the new Spectrum addresses one main challenge. This is to measure dimensional features on tiny and flexible structures.
But what's so special about tiny and flexible structures? Can you give an example?
Yes, sure. So the problem is that sometimes the wall thicknesses of the parts are very thin. And because of that, the parts are deflecting.
Okay.
Yeah, and with our X60 sensor family, we are able to perform those measurements and even be 40% faster than in the past.
So touching really sensitive parts that react to the touch element?
Is exactly to the probe.
Okay.
And when you think, for example, about electronics industry, I think everyone has it in their pockets, our phones. Those housings, they have those thin wall thicknesses, or laptop housings as well.
Okay.
Yes.
And that's when you need these, like, soft touch, is it called, right?
Yes, that's a soft touch mode we offering there. Yeah.
Okay. And so is the Spectrum then just another tactile measuring machine, or are there more?
Yes, now we
features?
talked about the tactile part of the Spectrum, but it's not only tactile. We also have an optical sensor called the Line Scan 1 sensor.
That they can just add to the Spectrum?
Yes, it's multiple, it's totally flexible, it's CNC changeable. And this sensor, this optical sensor, allows us to digitize selected areas of the parts to run analytical analysis to check the surface geometry.
So it's a multi-sensor technology, and it's about also be more efficient, faster.
Yeah, and it gives our customers more insights in their production and where maybe deviations come from.
Okay, can you give a short example of insights and deviations?
Yes, so for example, in the injection molded area, if you have this injection molding process, you can sure measure with a tactile probe diameters, distances, lengths, whatever. But if you use the line scan to digitize it, to have a huge point cloud, to analyze it, this helps to understand complex surfaces much better than only having dedicated features like lengths, diameters, and other characteristics.
Okay, so I understand the Spectrum is the perfect solution for efficiency and speed.
Absolutely.
But you mentioned other challenges before.
Yeah,
How do you address these?
It's true, yeah. So in general, we are continuously optimizing our systems, listening to our customers, and thereby also continuously innovating. And our Contura is a good example for the latest innovations.
Okay, but also Contura is not new to the portfolio.
That's true, but the Contura stands for flexibility. You can use, for example, multiple tactile sensors, multiple optical sensors. But the last innovation we added is the 4-axis scanning.
Okay, so what's 4-axis scanning?
Yeah, it's a tongue breaker, so to say. But this is the combination of the rotary table combined with a line scan sensor. And what we can do is we can super fast scan the parts on the rotary table. We have less invests in programming time. We have less qualification time. So it saves a lot of time, and the data quality is even better.
So I put a part on a table, it's fixed there,
Yes.
it rotates, and the line scan stays fixed, and it just measures all the individual points.
Yeah.
Okay.
So we save those multiple line scan positions. We can totally get rid of that.
How long does it take to measure?
It depends, yeah. So a 360-degree scan can take 1 minute, but can be even faster if you think about smaller parts. Yeah.
Okay. So it's also about speed, flexibility here.
Yes,
and
absolutely.
Okay, so now we talked a lot about these multi-sensor systems combining tactile and optical metrology, right?
Yeah.
When we look at regulated industries, for example, aerospace comes into my mind.
Yeah.
Do they have different challenges or other challenges?
Yeah, so aerospace is a very interesting customer segment for us. So they have very special requirements. Yeah. So aerospace.
What kind of?
Yeah, they need to measure 100% of their parts. Yeah. And all of these measurements with high speed, high accuracy, and all the results fully traceable throughout the whole production.
But I think many industries have the challenges of really high accuracy, but also, traceability.
Yeah.
So what's so special in aerospace?
Yeah, so aerospace, for example, if you look to the turbines, you have blades and blisks. Those parts, they have multiple process steps throughout the production. So, for example, casting, then milling, then grinding. Every one of those steps needs a measurement plan, needs to check the characteristics.
Okay, and it needs to be accurate, needs to deliver precise data.
Yes.
Okay.
And there, our Prismo comes into the game. When we talk about precision, efficiency, and reliability, the Prismo is our solution.
Okay, but also the Prismo is part of our portfolio, an important part of our portfolio for quite a long time.
It's true.
So what makes it so special for aerospace? Why is this our solution for aerospace?
Yeah, so for aerospace, we combine at the Prismo, again, the rotary table, our VAS gold sensor, and then we tweak the parameters, we optimize the settings, and together with our software, with our client software, Calypso, we are able, or our customers like Starrag are able, to reduce measurement time from 10 minutes down to 2 minutes, so massively saving.
Wow.
Yeah.
Okay. So Starrag is already a customer that is benefiting from the solution.
Yes.
So then Prismo is really a dedicated aerospace machine, isn't it?
It sounds like, yeah.
Yeah.
It can solve those special tasks, yeah. Or another special task, for example, is the gear metrology world, where we can measure spur, bevel, worm gears. Again, with our machine, the sensor, the rotary table, and the software, which is in this case the Gear Pro software. So the Prismo combines versatility and productivity.
Wow.
But very important to mention, it can solve special tasks the one day, but on the other day, it's a universal CMM. And this means we can be much more flexible and much faster, like those special measuring machines.
And it can also be used at line, as I understood, right?
It can be used at line with
Okay.
our special Fortis package.
Yeah.
It's also possible to use the Prismo
So it's
at line.
getting closer to production.
It's
and-
getting close to production, and it offers always the full automation potential.
Okay, and talking about automation, I mean, when I hear about automation, always these fully automated production lines come into my mind,
Yes.
where you have robots loading the parts
Yes.
and all these stuff. So, but I don't connect this with CMM. So how does
Yeah,
this
this-
apply to the CMM portfolio?
Yeah, first of all, right, you think about a lab. But
Yeah.
we are also offering our automation interface, first of all. With this interface, our customers are able to integrate their CMMs, our CMMs, on their own or with an automation partner. And this,
Into their production line. So
Into
also
their
with
line, yeah.
other systems that they're using,
Yeah.
X-ray systems, optical
Yeah.
3D, so you can all connect them
you
together.
connect them, you can set
Okay.
the sequences one after the other, and it allows to remote control the CMM.
Okay.
It gives feedback about the status, about the results, and much more.
Okay, that's quite interesting.
Yeah.
And what about the robot loading part that I think of? Do you also have
That's
a solution
true,
for
yeah.
that one?
I think you have always the robots in your mind,
Yeah.
right, when you talk about automation nowadays.
Yeah.
And yes, we also offer a turnkey solution. It's called Robot Load.
Okay. Yeah.
And and
Sounds logical.
sounds logic, yeah. And this contains two things. On the one hand, there's a part buffer, and this part buffer allows to really run the machine 24/7.
Okay, so all the time,
Yes.
day and night.
Day and night.
Okay, that's
and
very productive.
yes, and it also contains the part exchange with the robot on and from the CMM.
Okay.
This means with this solution, we are able to reduce the operator's efforts and have a totally ease of use solution for our customers where they don't need the high-skilled metrologists anymore.
Wow, okay. I really didn't know all these things and how we could integrate these automated solutions with our CMM portfolios. Very nice insights.
Yeah.
Since we are slowly coming to an end of our session today, Patrick, what are your key takeaways and how will these influence the measuring room in the future from your point of view?
It's a good question. I think one point we tackled already is really automation and fixturing systems. They are really important because even in the lab, in the measuring room, we want to have the 24/7 utilization of the CMMs.
To be more efficient, more productive.
Yeah. The second point I think is really the ease of use topic.
Yeah.
So software, no matter if it's programming software or if it's the reporting software,
Software is key.
software is the key. Absolutely. And one other topic which is very important, I would say, is that the CMMs in the measuring room, they are complemented by other solutions.
Okay, so it's not CMM or optical 3D, for example? Okay.
Yeah, it's the mix of it. So
Okay.
at-line and in-line, other systems play an important role. But in the lab, I really want to say the CMM remain. And the CMM plays the important role of reference measurements, for example, in first sample releases.
Okay, so CMM is not dead.
Definitely no.
Coming back to my question from the beginning.
I would say
so-
it's even more important
Okay.
as more technologies are there and as more reference measurements are needed.
And it's more about the connection of the systems and combine
Software.
them by software.
Yes,
Yeah.
exactly.
Okay. Thank you very much, Patrick. Thank you for the insights. I learned a lot about automating CMM systems that I didn't know before, about how important speed and efficiency is for our customers.
Great.
And to all of you out there, thanks for listening to our ZEISS Innovation Talk. Stay curious, keep innovating, and see you next time.